This video, we are going to talk about finding local maxes and local mins of functions. So to get started, first you need to remember the definition of critical number. So let the function f be defined at the number c. So c is in the domain of f is another way to say that. The number c is called a critical number of f if the derivative of f at c is 0 or if the derivative of f is undefined. Okay, so that's what a critical number is, and in a few of the previous videos we talked about how to find critical numbers of functions. All right, so the relationship between local extrema and critical numbers is this. If a function has a local maximum or local minimum at some point c comma f of c, then c is a critical number of f. Okay, so local maximums and local minimums occur at critical numbers. So let's take a look at the graphs of a few functions and take a look at that. So we're going to go back over the examples that we talked about in some of the previous videos. So in the video critical numbers, the function that we looked at was this polynomial x cubed minus 2x squared plus x minus 5. And in that video, right, we found that the critical numbers are 1 and 1/3. So here's the graph of that function, right? And we can see right here there is a local maximum right there, and sure enough, right, that happened at the critical number, one of those critical numbers that we found there, 1/3. Okay. And here at 1, we found that was a critical number, right? It was 1. So if we look right here at 1 on the graph, we can see that there is a local minimum. Okay. All right, so that was the first example that we did. In the video example, critical numbers example 1, right, we looked at this rational function here, x squared and 3x plus 1. So here's the graph of that function, and we can see that there is a local max right here, right? It's not the highest point, but it's the highest point in some small neighborhood here. And you can see at minus 0.667, that is negative 2/3 right there. So there's the local max. And then right here we have a local min, right? It's a local low point, and we can see that that happens at the other critical number 0 right here. Okay. All right. So that was the second. All right, example 1. Let's take a look at the function that we looked at in the video critical numbers example 2, right? And in that video, we found that there were two critical numbers, 0 and that's negative 1/4. I keep making that same typo there. Okay, so negative 1/4 is right here, and we can see that, hey, there is a local min right there. Okay, and then right here, we can see, hey, wait a second. In this example, right, we had 0 was a critical number, but there is no local max or local min right at 0 right there. So, right, not every critical number corresponds to a local maximum or a local minimum. So if you're after finding the local maximums and local minimums, right, it's not enough to just find the critical numbers. You have to go and check out the critical numbers to make sure that there actually is a local maximum or a local minimum there. So let's take a look at the difference between this, what's going on at this critical number right here and at this critical number right here. And it has to do with the fact of increasing and decreasing, right? So here the function was decreasing, right? It's going down as you go from left to right, decreasing, decreasing, decreasing. And then right here the function switches to increasing, right? So at local minimums, what's going to happen is the function's going to decrease until it hits that critical number, right? And then it's going to start increasing again. At this critical number, right, we didn't have that behavior. The function was increasing, 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 right? And then after the critical number, right, it's also increasing like this. So there was no change from decreasing to increasing, or vice versa. Okay. If we go back and take a look at the situation with the local max, right? The local max, it was increasing, right, until it hits here, and then it starts decreasing again. Okay. So we have that same behavior, right, at a local max, just sort of in reverse, right? It increases until it hits the critical number, and then it starts decreasing again. So when we have that behavior, we're going to have a local maximum. Okay, so that's the difference between those two cases here. And so that observation is usually what's called the first derivative test. So in the first derivative test, we have some differentiable function f, right, on some interval I, and we have a critical number of f in that interval. So if the sign of the derivative switches from positive to negative at c, right, then f of c is a local maximum. So positive, right, if the derivative is positive, what that means is that the original function, right, is increasing. So the original function's going up, right, and then it switches to negative. The derivative switches to negative. That means that the original function is decreasing right here. So we're kind of in this situation right here, where the function's increasing. This means that the derivative of this function would be positive, right? And then the function, the derivative is negative. That means it switches to decreasing like that. All right, and a similar situation when we have from negative to positive, right? If the derivative is negative, right, to the left of the critical number, and then positive to the right, that means that the original function was decreasing, going down, right, and then going up. So that must mean that there is a local minimum, right, at the critical number. All right, and then finally the last case of the first derivative test, if the sign of f prime doesn't change at c, right, then f of c is not a local maximum or a local minimum of f. Okay, and so that's sort of the situation that we had in this third example. The function was increasing, right, and then increasing here. So in terms of the derivative is going to be positive here, and it's also going to be positive here. There will be no switch of the derivative at that critical number. So anytime you have that behavior, you won't have a local max or local min there. All right, let's take a look at an example. All right, in this example, we have a function f, and the domain, we're told that the domain of f is all real numbers, and we're told that what the derivative of f is. So we're told what f prime. So notice we're never given f here, right? All we're given is the domain of f and the derivative of f. And what we want to do is use the first derivative test to classify each critical number as a local max, local min, or neither. All right, so the very first thing that you're going to have to do, right, is find the critical numbers. And so we've done several examples of that, but this is a polynomial, and you would set it equal to 0. And this one's already totally factored for you, so it's just a matter of setting each of these factors equal to 0 and solving. So when I set this equal to 0 and solve, I get 0. When I set x minus 6 equal to 0 and solve, I get 6. When I set x plus 5 equal to 0 and solve, I get negative 5. Okay, so my critical numbers are negative 5, 0, and 6. Then what you want to do, right, is to determine where this, where the derivative is positive, negative, and so that will tell you, where the original function is increasing or decreasing. So we did an example of this in the increasing and decreasing video, right? You would take those critical numbers, put them on a number line, right? And then pick some test points. I would pick a point in this interval, a point in this interval, and a point in this interval, and this one, right? Then I would plug those back into the derivative here, and I'll get some number when I do that. And if that number is positive, like it would be over here, right, then I put a plus on that interval, okay? What that means is that not only that number that I picked, when I plug it into the derivative, it's positive. Every single number, right, in this interval will, when I plug it into the derivative, it will be positive over there, okay? And so if I do that for this function, just follow that same technique that we did in the increasing decreasing video, then you'll get some sign diagram that looks like this, okay? All right, and so once you have the sign diagram, then it's just a matter of using the first derivative test. So let's take a look at that. So there's our sign diagram again, so we can reference it. And we are going to take a look first at the critical number -5. Okay, so at -5, right, we can see that the function was positive, so the derivative was positive, and then it switched to negative, right? So the derivative switches from positive to negative. According to the first derivative test, right, there is a local max at -5. All right, since I didn't give you the original function here, that's about the most we can say. Sometimes they'll ask you for the local maximum value, right? And so you would take that -5 and plug it back into f to get the y value. We don't have that here. We don't have the formula for f, so that's the most that we can really say right here. All right, so here again, the function, the derivative was positive. That meant the original function was going up, right? And then the derivative is negative. That meant the original function is going down like this. So we would have a local max at -5. All right, next up, we have 0, right, is the next critical number right here. And we can see that f prime doesn't switch. It was negative here to the left, and it was negative here to the right. So there is neither a local max nor a local min right at 0 because the derivative doesn't switch. The original function was decreasing, then decreasing again. So no local max, no local min. Finally, the critical number 6, right? Here we can see, according to our diagram, the derivative switches from negative to positive, right? And so that meant the original function has to be decreasing and then increasing again, right? So what that means is that there is a local minimum at 0, okay? So now we've classified all the critical numbers as local maxes, local mins, or neither, okay? And notice that we did that without ever looking at the graph of f. We didn't even know what the formula for f was, right? All we did was look at the derivative here, okay? But just to better explain things, let's take a look at the graph of f, right? There is a way to figure out what that is, right? And this is one of the functions whose derivative, right, is that we got there. So, and we can see right here at -5, right, we have a local max, just like our prediction said there would be, right? Again, if they ask you for the local maximum value, right, you would take that -5 and plug it back in to the function f of -5, right, and you'd get 468.75. So if they're asking you for the values, which they might on the quiz, because they give you f, right, then you would just plug that in there. And then at 0, right, we said there was no local max, no local min, and you can see that's definitely the case right here. It's decreasing, decreasing, and it just keeps decreasing there. So there's not a local max or a local min at 0. And then down here at 6, right, we can see that there is a local min there at 6, just like our analysis before showed us or told us that there would be. Okay, again, if you want to find the y value and you have the function, all you would have to do is plug the 6 in there and get the local minimum value, right, which is negative 928.8 in this example. Okay. All right, and so that's it as far as classifying critical numbers as local maxes or local mins.